Alrighty, so the next section is on exponential and logarithm equations and inequalities. So we're going to learn a bunch of ways to solve when we have equal signs and inequality symbols with exponential and logarithms. So there's all different ways to solve this. So this is going to help you to figure out what's the best way to solve my exponential or my logarithm. All right, so the very first thing we're going to talk about are exponential equations, which these are very similar to what we did in the last section. Okay, we're still applying the rule where if you get the same base on both sides, then you can set the exponents equal to each other. So the goal is to make the bases equal and then set the exponents equal to each other and solve. Okay, which we did that already. So these are the examples we're going to do. All right, and then later on in class, we will do these awesome funsies. So go ahead and pause this video and watch example problems 1 through 3. Alrighty, now the next type of exponential equations are when the bases cannot be equal. So we cannot get the same base on both sides. Okay, so the idea for these, we're going to get the exponential on one side by itself. So nothing is multiplying or adding or subtracting to our exponential. And then the next step is to convert the exponential to a logarithm. So we'll be using our skills of converting from one form to the other. And then we'll just solve for x. Okay, which these are the example problems we're going to do. And later on in class, we will do these funsies. So go ahead and pause the video and watch example problems 4 through 6. Okay, so if you notice, we are now throwing inequalities into the mix. Okay, which these you actually solve the same way that we solved the previous two slides. So we're going to have some cases where we can get the same base on both sides, like we have here, which means you can drop your exponents down and your inequality symbol down. So if b to the y is greater than b to the x, that means that y will be greater than x. Okay, so on these, if you can get the same base on both sides, you will use this rule. Okay, if you cannot, you will have to convert it into a logarithm, which, if we ever convert to a logarithm, okay, this could cause your variable to switch sides of the inequality. Okay, and if your variable ever switches sides of your inequality when you are converting it into a logarithm, okay, your inequality must face the same direction towards the variable as it started. Okay, so if your variable is facing toward the inequality, okay, so if your inequality is like opening up toward your variable at the start, if you convert it to a logarithm, if your variable switches sides of the inequality, your inequality still must be opening up toward your variable. Okay, which if that doesn't make sense, we will go over this. This will occur in the last example problem on here, so example 9. All right, but we will be using the same properties we just used in example problems 1 through 6. We just now have inequalities. Okay, and then later on we'll do these funsies in class. So go ahead and pause the video and do examples 7 through 9. Alright guys, so now logarithms will be in the mix, which the first type of log equations we're going to solve is when the logarithm is on one side of your equation. Okay, so if you see here, which I'll fast forward, if you see here, there are log problems only on one side of the equal sign. Okay, so that's what we're going to be focusing on first. Now, something we're going to talk about later on in the example is when we solve these, the important one is that the number inside the log can never, ever be equal to 0 or less than 0. So to prevent that, each log that contains a variable in it has the risk of going less than 0 or equal to 0. So to prevent that, each log that contains a variable within it, you have to set that expression to be greater than 0, and then you solve it, and when you get done, you have to make sure that your answer is within that interval, and if not, we're going to call our answers extraneous. Okay, which if that doesn't make sense, it'll probably make more sense in the example video as I go over it. Now the steps we're going to be using, we will be combining our logs into one log using our properties we talked about. So you might be using the product property, the quotient property, or the power property to do that. Okay, we're going to get the log on one side by itself. Okay, so nothing added or subtracted or multiplied to the log. We're going to convert that thing into an exponential now, so we're reversing the process. And then we solve for x. And very importantly, at the very bottom, it says check your answer. So when we set the logarithms that contain a variable within it to be greater than 0, if our answer is not in that interval, like when we solve this, if we get x is greater than 3, and you get x equals 2 as your answer, that can't work. So your answer would be called extraneous. Which again, if that doesn't make sense, we are going to go over them in the example videos. So we'll be doing 10, 11, and 12. Now this last one we're going to come back to because we have to have some factoring skills in order to solve that one. Okay, so go ahead and pause this video and do examples 10, 11, and 12. Okay, so like I said, before we get to 15, we need to review factoring. Okay, so we are going to be reviewing 13 and 14 right here, which I'm going to teach you a method called slide and divide, which are in a factor. And we're also going to talk about how to find solutions once you do factor. Okay, so if you already know how to factor from your previous math classes, you can try to do 13 and 14 on your own. Okay, but otherwise, you can follow along in example problem 13 and 14. So go ahead and pause this video and watch example 13 and 14. Okay, so now that we have tackled how to factor and find solutions once we factor, we can now talk about how to solve number 15, which this is the same kind of problem as before. It just requires an extra step of factoring. So go ahead and pause the video and watch example 15. Okay, the next kind of logarithms we're going to talk about are when the log is on both sides of your equation. So I'm going to skip ahead real quickly. If you see here, logs are on the left-hand side of this equation and on the right-hand side. Okay, which actually, these are actually a lot faster to solve than your previous ones. Okay, so don't get freaked out by all the logs. They're not going to be worse. They're usually a lot easier. So the process we use to do this is, first of all, you're going to combine your logarithms into just one log on both sides of the equation. And again, we do that through properties of the logarithms. So things like the product property, quotient property, and power property. Once we have that on both sides, so one log on both sides, kind of like in 17, we will be able to drop our logs on both sides and then set whatever's inside the log equal to each other. Okay, so like in 17, since we already have one log on both sides and they contain the same base, we could drop the numbers inside of the log and set them equal to each other. So like I could drop x plus 1 and set it equal to 5. Okay, which I will go into more depth on the example video. And after we do that, we solve for x. But like before, we have to check for extraneous answers. So any log that contains a variable in it, you have to set it greater than 0 at the beginning and solve it for x. And if any of your answers are not in that range, they are called extraneous. So be on the lookout for those. So go ahead and pause the video and watch example 16 and 17. And these are the funsies we'll do later. Holy hot dog. Okay, so the last type of problem we're going to talk about are logarithm inequalities. Okay, which, like before, we solve these just like log equations now, like when we did with exponentials. We solve the inequalities just like we did the equations. Okay, so we just now have an inequality in the mix. So we're going to first set all the values in the logarithm that contain an x in it to be greater than 0, like we've been doing. Okay, and like we talked about in the video, this will tell us the lowest value that your inequality will be. Okay, so we're going to use the same properties as we did before. We just now have an inequality. Okay, and on these, we could have something called a lower bound situation pop up, but I'll wait for you guys to watch the videos to find out what I'm talking about by this lower bound thing. Sorry guys, that's not what I wanted to do. And these are the funsies that we will do later on in class, so you're going to have to wait to do those, even though I know you're dying to do that. Alright, and that will be it. It's been so much fun, you guys.